So in our previous problems, we haven't really worried about running out of one reactant versus the other. The problems have always been set up that you will have plenty of your second reactant. In one of our problems, it said specifically you react with excess. So now we're going to look at what happens if you don't have excess. What happens when we run out of a reactant? So if you run out of one of your reactants, what's going to happen to your reaction? Well, your reaction's going to stop. If you run out of one of your reactants, you cannot continue reacting. So the reaction will stop. Okay, so if the reaction stops, that's what's going to limit how much product is made. That's why we call these types of problems limiting reactant. We are going to run out of a reactant that will limit how much product we can make. But then how do we know which reactant's going to run out first? Well, you can't just look at a problem and know, oh, clearly that one's going to run out first. We have to compare mole ratios. We have to actually figure out and do a little extra math to figure out which is going to be our limiting reactant. So let's look at how we do that. Let's look at a mole-to-mole stoichiometry problem to kind of work our way into this limiting reactant idea. Okay, so this problem says you react 4 moles of H2 and 4 moles of O2 to produce H2O. So let's figure out what we're going to run out of first. Now, I have my balanced chemical reaction equation, so I have 2 H2 plus 1 O2 produces, oops, that's missing a 2 H2O. Put all my coefficients in red just so that they stand out. So we have 2 H2 plus 1 O2 produces 2 H2O. So let's just start with H2. Let's start with our hydrogen. So if we have 4 moles of hydrogen, how many moles of oxygen will we need? We're ignoring the fact that we have 4. Let's just figure out how much we need. If we reacted all 4 moles of our hydrogen, how many moles of oxygen would we need? Well, we have 4 moles of H2. If I look at my coefficients, I know that for every 2 moles of H2, I need 1 mole of O2. So if I do 4 times 1 divided by 2, I need 2 moles of O2. So if I'm going to react all 4 moles of my hydrogen, I need 2 moles of oxygen. So now I go look at my problem. Do I have 2 moles of oxygen available? Yeah, I have 4. So this looks like our hydrogen's going to run out first. But let's check this. Let's go the other way. So let's say we have our 4 moles of oxygen. How many moles of hydrogen would we need? Well, if I have 4 moles of hydrogen, or 4 moles of oxygen gas, if I look at my coefficients from my balanced chemical reaction, I know that for every 1 mole of oxygen, I need 2 moles of hydrogen. So if I do 4 times 2 divided by 1, I need 8 moles of hydrogen. So let's divide these. Now, do I have 8 moles of hydrogen? No, I only have 4. So this is not possible. So we are not going to react all 4 moles of O2, which means we will have leftover oxygen, which means that our limiting reactant is our hydrogen. Because we're going to have leftover oxygens, we're going to run out of our hydrogen, so our hydrogen is considered our limiting reactant. Now we use our hydrogen to figure out how much water we produce. But that's not what the question's asking. What we really wanted to focus on what was our limiting reactant. So now we're going to use that same idea and apply it to a little bit more complicated problem. So in this problem it says you react 15 grams of N2 with 20 grams of H2. How many grams of NH3 will be produced? Now, you know that this is a limiting reactant problem because you don't have a reactant in excess. I give you specific amounts for each of your reactants, which means you have to figure out which is going to run out first. So we have to do that limiting reactant part. But before we can even do that, we have to convert our grams into moles. So let's convert 15 grams of nitrogen into moles. So I know that for every 1 mole of nitrogen, so nitrogen is N2, so I'm going to have 2 times whatever the number is on the periodic table, 14.007. So I get 28.014 grams. So if I have 15 grams, I have 0.535 moles of nitrogen. Okay, now I'm going to do the same with my hydrogen. So I have 20 grams of hydrogen. I know that for every 1 mole of H2, I'm going to have 2 times 1.0079, 2.01 grams of H2. So 20 divided by 2.01 gets me 9.95 moles of H2. Now, just looking at those numbers, if we have half a mole of N2 and almost 10 moles of H2, what do you think is going to run out first? Your nitrogen's going to run out first. But let's just check to make sure. Notice we didn't realize there was that dramatic of a difference until we converted to moles. 15 and 20 are pretty darn close when we look at grams. But when we convert to moles, it's a much, much bigger difference. So you can't forget that first step. So now, let's see what we need. So if we react all 0.535 moles of N2, how many moles of H2 would we need? So I'm going to look at my coefficients from my balanced chemical reaction. So for every 1 N2, I need 3 hydrogens. So if I do 0.535 times 3, oops, typed something in wrong. I get 1.605 moles of hydrogen. So if I react all of my nitrogen, I need 1.605 moles of hydrogen. Do I have 1.605 moles of hydrogen? Yeah, I have almost 10. I have plenty. So my nitrogen is going to be my limiting reactant. So it's this nitrogen that we're going to use then to figure out how much NH3 we produce. So if we have 0.535 moles of nitrogen, I need to figure out how many moles of NH3 I'm going to produce. So if I look at my coefficients, I would see that for every 1 mole of nitrogen, I get 2 moles of NH3. So 0.535 times 2 gets me 1.07 moles of NH3. And then finally, my question asks for grams, so now I need to convert moles to grams. So if I have 1.07 moles of NH3, for every 1 mole of NH3, we have to add up to figure out the molar mass. .03 grams of NH3. So if I have 1.07 times 17.03 gets me 18.2 grams of NH3 as my answer. So really, when you're looking at a limiting reactant problem, the only difference is you have this additional step at the beginning where you have to figure out which one's going to run out first. And the easiest way to do that is just to run both scenarios. See if you have enough of, in this case, hydrogen to react all your nitrogen. And then flip it the other way. See if you have enough nitrogen to react all your hydrogen. That'll tell you which one's going to run out first, because it's always comparing back to how much you originally have in your problem. Once you figure out your limiting reactant, it's your limiting reactant that's going to be used to predict how much product you make, because your limiting reactant limits how much product you can make at the end of a reaction.